Okay, this is the first question on the 2010 exam. It's an NPN circuit as usual, but we have the complication that the emitter here is at -5 volts rather than the more familiar level of ground. So first thing to do is to figure out what's going on with the base emitter connection. You remember that the base to emitter connection is as if there were a diode, and that means that if this is conducting from base to emitter, there will be a 0.6 volts difference between them, just like a regular silicon diode. So that makes this point, point A, not plus 0.6, but rather minus 4.4, because that is referred to the voltage of the emitter instead. Now, let's look at this 100K resistor. It's between plus 5 and minus 4.4. I'm going to approximate that as 10 volts. You could be a little more accurate if you want, and that means that the current through there is 100 microamps. So we've got the voltage at point A, we've got the current into the base. Now, realistically, a transistor isn't going to have a known gain of exactly 100, but that's what the problem says, so let's go ahead and use that. That means that unless the transistor has saturated, unless it's doing everything that it can to conduct current, and it just can't anymore, as long as it's not saturated, the current here is going to be 10 milliamps from collector to emitter. And we better check that the transistor does not wind up, in fact, saturated. So here's this load resistor of 600 ohms, and the voltage across that with 10 milliamps going through it is 6 volts. Okay, is that possible? Well, if you thought that the emitter of the transistor was at ground potential, you'd say no. But here the emitter of the transistor is at -5, and so that puts this point, the collector, at -1 volt. That's the answer to the question, but we also have to be careful to check that, is that okay? Is the transistor in saturation? Is the voltage from collector to emitter? You know, if the emitter were at ground, you'd say, oh no, the transistor must be saturated. Its collector can't go below 0. But here, the collector can go below 0 because the emitter is at -5. So this transistor is just fine, and there are the answers to the voltage at point A and the voltage at point B.